Okay. So I was thinking today would be we do some chapter 19 problems, either that or we go back and review for the test, depending on how comfortable you feel with 19 already. Drink some water. Start with this one. Okay, that's fine. Over here, I'll try this one first. Is this it? Yep. Break down the gist. So for part A, we have R2 2I minus equilibrium with 2BR minus, and then plus I2. And then for part B, we have 2Ce4 plus 2Cl minus, equilibrium with Cl2 plus 2Ce3 plus got that. BR2 plus 2B minus goes to 2BR minus is Ecell of 1.07. We have I2, no, yeah, I2 plus 2E minus goes to 2I minus, and then Ecell is 0.53. This one, Ce4 plus E minus goes to Ce3 plus, and then that's 1.61. Oh, Ecell. Cl2 plus 2E minus goes to 2Cl minus Ecell is 1.36. And then, where did my notebook go? There it is. And then we also know what delta G not equals negative N F E cell not, and then delta G naught equals negative RT natural log of K. And then F is 96,500 joules per mole. Volts. Yeah. So I wrote all that down. I'm gonna stop sharing this. I wrote all that down up here, basically, all the stuff, even the equations up in the top corner. Let me make sure on my Faraday's. Hold on, I'm double checking my Faraday's constant, or the units anyway. Joule volts per mole, cool. Oh, and then the cell equals E of the cathode minus E of the anode. Okay. Are you guys working on this, or should I do one part? Hello, Abby. We're just doing this problem. It's oh, which one was it? Oh, you're working on it. Good. This is problem 1923, I think. Yes. And we're looking for the equilibrium constant for both of these reactions. All right, and I gave you all the, hopefully you can see all these equations over here. It's cathode, anode, natural log K, that's E cell naught up there. And then Faraday's constant is down here as well. Cool. I'll give you guys, just let me know if you get stuck or if you need help somewhere. So we are looking for K, right? Yes, that is correct. So you can tell me K for this one, and then K for this one. I'm lost. Would you mind working them out? No, that's fine. Okay. I'm stuck too. That's all right. I'm just gonna start with part A, and we'll come back to this one. Yeah, we'll come back to it. No problem. I erased Faraday's constant. Rip, that's fine. Okay. Faraday's constant is 96.500 joules, volts, moles. Okay. All right. Okay. So we're looking for K, right? And hopefully you can notice by this long chain of equations you have here, we're going to find Ecell first, right? Find Ecell. So Ecell will give us delta G naught, and then delta G we can use to get K. All right. Okay. I guess we should say that all these are at 25 degrees Celsius. Set that in problem, but I didn't write it down. So, okay. All right. So first, okay, Ecell, the Ecell, the cathode minus the Ecell, the anode. All right. So do you remember how to tell if it's in this reaction, if it's at the cathode or the anode? Red cat, yeah, red cat. For me, it was red cat and ox. It was red cat and ox. But if you just know that, you don't need the other one. But yes, so the red cat. So we do our reduction, we do our oxidation numbers, right? So this one, 0, easy because it's a neutral, a single element with no charge, so 0. Single element with the charge, so this one's -1. Single element with a charge, -1. Single element, no charge, 0. Okay, so Br is reduced. I'm gonna write it here. Br is reduced. So it's a cathode. I is oxidize. So it's the anode. All right. Everyone good there? Yes. Awesome. Sweet. Okay. so now we can use our Ecell equation. So we write that E of the cell, Ecell equals, so the cathode, so 1.07 minus our anode, so it's 0.53. Excuse me. And so our Ecell on my calculator, 0. Okay, so that's our 0.54 volts. Okay, now we have Ecell. We can get delta G. All right, so let's see, delta G. G naught is N, or negative. I don't know if you can see that. It's a negative sign. Negative N. All right, who remembers what N is? Number of moles. Yeah, so it's the number of moles of the electrons, right? Yeah, the number of electrons canceled out. Okay, correct. Okay, we look up here. We see that this is just these two switched, right? Just flip it and then they added them together. So for us, our N is 2, right? You see that these are the electrons we canceled out. So we have N is 2, right? Everyone? Yes, okay, cool. So put Faraday's constant, 96,000 joules, moles, volts, times our Ecell, which is 0.54. And so delta G naught is, what is -2 times 96,000 times 0.54. I got -103. And I'm just gonna keep 36 fixed. So 4 times 10 to the third joules. I'm just gonna leave it in joules. Okay. Still good here. Yes. Okay, last step. Well, I guess you could have combined these two equations, but I'm just taking it step by step. So now we also know that delta G, so delta G naught, I'll do it in a different color. Delta G naught equals negative RT, oh, I forgot to give you R, rip. T natural log K. Right, plug in our numbers, so we know that delta G is -104 times 10 to the 3. Well, this is joules per mole. 10 to the 3 joules per mole. And that's going to equal -8.314 joules, moles, Kelvin times our temperature, which is this in Kelvin, which is 298 Kelvin. So 298 with the natural log of K. Okay, divide by those two. So natural log of K is positive, so 41.8, no units, and then K, put everything to the E, is got 1.49 times 10 to the 18th. All right. Got it. Sweet. Okay, so now if we look, so I'm just going to share the other screen. Hold on, so I don't have to erase this yet. Okay, and the other one's going to be exactly the same, right? Kind of, a little. Right. Everything is basically going to be the same. The only difference is what E-cells you pull. And then the question becomes, okay, so in here I have 2 CE4 plus and then 2 CE3 plus, right? But my reaction, I only have 1. So do I need to do anything to my E-cell? That's the question, right? Please. Okay. All right. Multiply, do you multiply it by 2? No, you actually don't. You don't need to fix it. So whenever you, in the next part, so here, I'm gonna erase this for right now. What don't I need? I'm gonna erase all of this. Oh, I should have. That's fine. I'll figure it out later. So in part B, you actually don't have to multiply it by anything. You just leave it. It doesn't take into account the coefficients. It's weird. Oh yeah, stoichiometry doesn't matter. Yeah, that's right. So 2 CE4 plus what was it? Was it CL? That's 2 CL minus goes to, where's an equilibrium with? CL2 plus 2 CE3 plus, right? And then for E-cell, the numbers I get, again, we check to see if the, I guess I should probably make sure you can see this. Again, we just check the which one's which. Okay, this one goes from 3, 4, plus 4. This one's -1, 0, plus 3. Right. CE is reduced. So it's the cathode, and then Cl oxidize. So it's the anode. Right. Then you look at your table and you see that E-cell not is your cathode, which is your CE, which is 1.61, minus your anode, your Cl, which is 1.36. So you get an E-cell, right? No 2 right there. Ecell not is what? .25. And then we do it all over again. We do our shenanigans. We do delta G. It's negative. Again, if you look, share it with you. Can Ecell be negative? Yeah, it could. Let me finish this, Eugen, and then we'll address that. So if we go back to if we look at the reaction again, look at our reaction. We multiplied this one by 2, so we had 2 electrons, and then 2 electrons in that one as well. So 2 again is our N. So 2, Faraday's constant, and then our Ecell. So delta G, negative 2, 6, 0. 48.3 times 10 to the 3 joules per mole. Also, never forget that this is in joules per mole, joule volts per mole. And so if you go calculate delta G in kilojoules, you got to make sure they're in the same units. Just a side thought. Okay. Okay, we have our delta G now. And I'm going to rewrite my K. So K is E to the negative delta G over RT. Right, and so from that, K is right. This is just me rearranging that. 8.314 times 298. Okay, I got a K of 2. 0.97. No, 87. Oops. Times 10 to the 6.8. Okay. Did make sense. Awesome. So this is B. This is from me later. That's the answer we got for part B. And then here's the answer we got for part A. Okay. Alrighty. Okay, so now the question of can Ecell ever be negative? So what I'm going to do, I'm going to erase this now. take this, just gonna flip it. If I gave you this reaction, okay, now here we have the, same thing, just flipped it. So, we check our things again. So 0, +3, +3, +4, -1. All right, so now our Cl is reduced. So it's the cathode. And then our Ce is oxidized. And it's the anode, right? So you can see all I did was flip the two where the two things went. So now when I calculate my Ecell, so Ecell naught is going to be my 1 point, what was it, 1.3 something? 1.36 minus my 1.61. So that's going to give us our negative 0.25, right? Right, folks? Okay, I was just wondering because in all the problems we did in class, E cell was positive. Yeah. So all the problems we did in class were for ideal. Well, he oriented all the cells going in the right direction. So he made it so that the correct thing was being the anode and the correct thing was the cathode. So there is a chance. So if you get if you're doing if he just tells you hey, I want you to put, I think there's actually a problem in here somewhere. It's okay, here. You know what? So if I gave you something like this, let me show you what I'm looking at. What? So if I gave you a question like this one, where I calculate right, so we're looking for EMF or the E cell. What's this? Right. I didn't write down the reduction potentials for those. Okay, So here, and the problem is we don't know what the reaction is. Or you have to. I mean, you could figure out what it's supposed to be. Okay, so now I just have to take. I have to basically just take these two half reactions, right? I know my two. I can write two half reactions between those two things. So Al 3 plus 3E minus goes to Al. Is that right? And then so Ag plus E minus goes to Ag. So one thing you can tell, you're obviously going to multiply this one by 3 to get our electrons to go away. So now the question is, which one of these is reduced and which one of those is oxidized? So you could just look at your, if he gives you that chart, or here's another, you could look at that and see which one's higher. And so the higher it is, the more likely it's going to be reduced. Another thing we could think about is if we look at our Ecell, remember you want it to be positive, it's spontaneous. When Ecell is greater than 0. So if I do Ecell, E cathode minus E anode, another way to tell that which one's going to be reduced, or the cathode, and which one's going to be oxidized, or the anode, is okay. If I want this to be positive, I want the cathode's number to be bigger than the anode's number. So that goes ahead and tells me that this guy should be my cathode and this guy should be my anode to get me a positive Ecell. If I didn't do that, if I just guessed, and I guessed that this one was a cathode and that one was an anode, I would get a negative Ecell, which is not spontaneous, right? And so it wouldn't occur at room temp. So you would want Ecell to be positive. Yeah. Ecell, when it's spontaneous, it's the reaction is spontaneous when it's positive. Yes, correct. Right. That's just from our delta G thing, right? Delta G. We know the reaction is spontaneous when delta G is less than 0. We know delta G is negative NF E cell, right? So if I want this to be negative, these two are always positive, right? The only way this is negative is if this guy is also positive, right? If this guy is negative, then this guy's positive, right? And so non-spontaneous. So for your cell to occur, right, for it to be in the right direction, right? Because the only thing that's different is that you flip it. You want Ecell to be positive. Okay, did all that mumbo jumbo make sense? Yes, cool. Right, and so the rest of that problem isn't too bad. You just, so our reaction, you would add these two, you would flip this one, right? Because this one's going to be oxidized, and right now it's being reduced. So the Al goes to Al3 plus 3E minus. Then we add them together. So our overall reaction would be 3 Ag plus Al. And then I'm being lazy with my states, but you should put them in there. Al3 plus 3 Ag. Calculate Ecell, no problem. So Ecell not, it's going to be my 0.80 volts minus my negative 1.66. Again, not multiplying it by 3 because our stoichiometry doesn't matter. So what's that? That's 1.66 plus 0.8. I didn't type it in, idiot. 1.66 plus 0.8 is my 2.46 volts. It's my Ecell. Make sense? Cool. Awesome. Do you want to, so we'll do one more. Should we do another 19 problem or should we do something review? What are you feeling? Test review. Yeah. All right. That's what I mean, test review. So like something from either 16, 17, or 18. Can we do 18 for the quiz? Yeah. Let me go. Anything particular? I have one. What? I have a question. Let me see what it's about. I have a question about finding when delta G here. Okay, nothing particular. So let's do this one. Um, let's do this. Share your views. Okay. No. All right, read that. Look at that. I'll give you a chance to do it first, unless you have no idea what to do. So just let me know. I'll be writing it on my board. So let me give you, here, I can write it over here so you can give you this. Aha. Oh, let me also give you this. When I say favor the formation of the products, I mean the forward reaction is spontaneous. I don't know if that confused you, but just in case it did, it's clarification. Again, let me know if you're stuck. I'm stuck. All right, no worries. Okay. Did you, oh, hold on. Let me edit this. Reaction. Also reaction. Okay. It's for my sanity. Okay. All right, so to determine if it's spontaneous in the forward direction, right? I need to know if the delta G of the reaction, so I could just imagine. Can imagine it's just a straight arrow, so don't concern ourselves with that right now. I need to know if the delta G, when does the delta G of this flip from becoming positive to negative? All right, okay. At 0, correct, right? So I need to, I'll flip it over here. Stop that for right now. We'll go back. So I need to know when does delta G, we'll do that for right now, equals 0. Or in any case, when that equation I gave, when does delta H naught minus T delta S naught, when does that equal 0? And T is our variable, right? Because I can find S, you can find H, you can find S, then now you just need T. Right? Okay. So looking over here, we'll get, let me make sure, is this balanced to 1? Yep, okay. So remember our delta H is just the, here, I'll just show you this. Okay, stop that for now. So delta H is of my reaction. It's going to be my product, so my CO, the H of my CO, which is negative 110.5, plus the H of my H2, which is 0, minus the H of my H2O, which is negative 241.8, plus my H of my C solid, which is 0. That's going to be, sure. Are we given that equation? Yeah, you'll be given this. The delta G, or this one, or the delta G equals delta H minus T delta S. The delta H. I think you're given that one as well. Check my old quizzes. They're not in here. Yeah, I think you. Someone correct me if I'm wrong, but I think you get like delta H reaction equals the sum times n of the products and minus the sum n the reactants. I think, hold on, it might be on Canvas. Okay. Awesome. Okay. So, and then the 131.5 kilojoules per mole. That's our delta H. Do the same thing for delta S. So if I look at my thing, so I got for CO, it's 197 point, it's above, 197.9 plus 131.0 minus my H2, so 188.7 minus my 5.69. And so here I get 145.89 joules, moles, Kelvin. Okay, now we have those two numbers. All right. Now that we have that, we take it and so I'm gonna write them up here. Or I'm gonna put them in our thing, so now I have my equation is 0. Well, if I solve this right now, I get that T is my delta H over my delta S. So I'm gonna do that. So my temperature is gonna equal, again, that's stressing this a lot, kilojoules right there, joules right there, they have to be the same. So I'm just gonna say 131.5 times 10 to the 3 joules per mole over 145.89 moles, Kelvin, joules. So my temperature, my units cancel out correctly, right? I just end up with Kelvin. This, that's 3. I don't know why I wrote 5. I got 3 right there. Okay, and I got 899. Oh, 900. How many sig figs do I want? I'll do 4. 900. So there's the temperature. It starts to favor our products if I did that right. Let me double check. One question is, oh, it's 103. Hold on. Oh, hold on. Math error. 3, 4, 5, 1. 3, 4, 5, 1. So 6.1. Better. There we go. Fixed it. That kind of makes sense. Got it. Cool. So yeah, this is what you're going to be doing anytime it asks you, like, at what temperature does this become spontaneous? At what temperature is the forward reaction favored? At what temperature does this reaction become non-spontaneous? So anything of that form is you'll be looking at when does delta G equals 0 or when does this equation equals 0. Makes sense? Everyone get the same thing I got? If it asks when the run begins to favor the formation of the reactants, would you be looking for when it is not spontaneous? Yes. Yeah. Yeah. You would be looking for when the forward reaction is not spontaneous. Yes, that is right. Right, because if I flip my reaction, if I flip it, I change the sign of delta G, right? So yeah, you're right. So if the forward is non-spontaneous, then the backwards is spontaneous. So good. Good question. Oh, another quick note. So remember, so this has both positive H and S, right? So you would flip delta H and S. Yes, correct. Yeah, these two would flip as well. Yeah, that's right. Yeah, they all have that. Well, that's because they're state functions, and it doesn't matter. It just matters where you start and where you finish. So if you go backwards, it's just the same number, but it's the opposite sign for all of them. Anyway, the tangent I was about to get on. So here, both of these are positive, right? And remember we said it's spontaneous at high temperatures, right? They would say it's spontaneous at high temperatures, high temps. It's spontaneous at high temps. It's spontaneous. Right, and then maybe the question, maybe you might have been asking if you cared a little bit, is what temp are you referring to right here? What is high? So there it is. Anything above that is spontaneous, right? Little side note, if you're curious. And anything below that is not spontaneous. Is it spontaneous at the temp or only above that? So at the temp, it's at equilibrium, or so at this temp, delta G is 0. So it's at equilibrium. So it's not going to, so the rate, so it's at equilibrium. So the rate at which it goes back is the same as the rate at which it goes forward. So basically you get nothing going on. Or I guess you do get something. Something is going on, but nothing's really changing. So above this temp, you start to favor going that way. So you have more of a production of products going on. Did I answer your question? Yeah. Okay. Is there anything you guys want to do? It's about that time. So we can be done unless you have something you want to talk about right now. You're good. Sweet. You're welcome. No problem, guys. Girls. Hope that doesn't offend you. All right, no problem, everyone. Oh, wait. Before you leave, let me see if this poll works again, or if it's broken. Okay, I'm gonna redo it. I'm thinking of using this to see when people are done, so I don't just, or if they're stuck. Oh, sweet. It still works. Awesome. All right. Okay, now I'm done. You're all good. You're free to go. I'll see y'all later.